The IP address is a Layer 3 logical address that identifies and locates each device in the IP network. There are two versions of IP we use today, version 4 and version 6. In this lesson, we'll be focusing on version 4. We'll look at the format of IPV4 addresses, subnet masks, address classes, and a few special IPv4 addresses you should be familiar with. An IPv4 address consists of 4 decimal numbers separated by a dot that can range from 0 to 255. An example of a valid IP address would be 192.168.5.42. The IP address is represented as a decimal number to make it easier to work with, but computers use binary numbers. Each place in the IP address is known as an octet because it consists of 8 ones and zeros. That's why valid IP numbers can only be between the range of 0 to 255, since there are only 256 or 2 to the 8th power different combinations of 8 ones and zeros. Each IP address is separated into 2 parts, the network ID and the host ID. The subnet mask is what tells us which part is which. The subnet mask looks like an IP address in that it also has 4 octets. With simple subnet masking, each subnet mask either has a 255 or 0 in each octet. Octets with 255 represents the network ID, and octets with zeros represent the host ID. Once assigned, the network ID stays the same for all IP addresses on that network, and the host ID changes for each IP address. In our example, all IP addresses in the network start with 192.168.1, and each host has a different host ID value in that 4th position. In this case, it's 42. If we change the subnet mask to be 255.255.0.0, our network ID would be 192.168, and the host ID portion would be the last 2 octets. So the IP addresses 192.168.1.42 and 192.168.8.5 would be on the same network because the network IDs are the same. When configuring an IP address on a host, you must supply the subnet mask in addition to the IP address. A default subnet mask can be identified by the address class. IP addresses are divided into classes, with each class having a different default IP subnet mask and IP address range. A Class A IP address starts with a value between 0 and 127. The subnet mask is 255.0.0.0, which means that just the first octet is the network ID, and the last 3 are the host ID. This means that we can have over 16 million or 2 to the 24th power addresses per network because there are that many different combinations of 24 ones and zeros. A Class B address starts with 128 through 191, has a subnet mask of 255.255.0.0, and gives us 65,536 address IDs. The Class C network range is 192 to 223, with a subnet mask of 255.255.255.0, and gives us 256 addresses. Now, Classes D and E are specially reserved classes and don't have a default subnet mask. Class D starts with 224 through 239 and is reserved for multicast operations. Class E starts with 240 through 255. This class is reserved for experiments and research purposes only. Chances are you will never work with these IP classes, but you should be aware of them and what they're used for. IP addresses are assigned in blocks by the Internet Assigned Numbers Authority, or IANA. This organization keeps track of IP addresses and helps ensure that addresses aren't duplicated over the Internet. Users don't need to reach out to IANA to get an address assigned. Instead, your Internet Service Provider, or ISP, is assigned a large block of addresses by IANA. When you connect to your ISP, they lease you one of the IP addresses they were given by IANA. Each IP class reserves a special set of addresses that are used only in private networks. These private IP addresses stay on the internal private network and aren't used on the Internet. When a device needs to send data over the Internet, it uses the public IP address that's been assigned to its network by its ISP. This means that users in one network can have the same private IP address as users in another network because their public-facing IP address can be different. These private IP ranges are defined in the Internet Engineering Task Force Memo RFC 1918. For Class A networks, the private IP address range is 10.0.0.1 through 10.255.255.255. The Class B private network range is 172.16.0.0 through 172.32.255.255. And the Class C private range is 192.168.0.0 through 192.168.255.255. Using private ranges allows us to expand the use of IPv4 addresses since anyone can use them inside their own private network. Now let's look at some of the special IP addresses you need to be aware of. The first special IP address that you'll run across is the Automatic Private IP Addressing, or APIPA. This special address is used when a device is unable to be assigned an IP address automatically, and there's no manual configuration. In this scenario, the device uses APIPA to assign itself an address that starts with 169.254. So if you're having problems connecting to a network and see that you have an IP address starting with 169.254, you know that there's an issue with the IP system or the way in which it normally obtains an IP address. Each device also has a local loopback address of 127.0.0.1. This address is also known as localhost or home. This address is reserved by each network interface card and is used for testing purposes. For example, you can ping 127.0.0.1, and if you get a response back, you know that the network card is able to send and receive packets. The next special address is the broadcast address. The broadcast address is the last IP or largest address in the network's range. For example, if our network ID is 192.168.1, 192.168.1.255 would be the broadcast address. Any packet sent to this address is sent to all devices on that network. The last special address is the network address and is the first or smallest IP address in the network's range. So in our example, that would be 192.168.1.0. Now you can see why these last two special addresses are reserved and can't be assigned to a host. This means that a host address can never end in a 0 or 255.